Jai Hind, welcome to the course Network Analysis and Synthesis, and I am going to discuss about the waveform synthesis. Waveform synthesis is carried out to study the behavior of complex waveform in terms of singularity functions and mostly unit step and RAM. So, we are going to discuss the synthesis of a wave shape using singularity function, which we have studied earlier in the previous video lectures. Different type of singularity functions: unit step, ramp, impulse, and doublet. So we'll take the help of unit step and ramp function to synthesize a complex waveform. So start with very simple. Take this very simple square pulse. So this pulse starts at t is equal to A and terminate at t is equal to B. So this particular square pulse we have to synthesize using the step function. So we just earlier we have this type of wave shape. Suppose this is your time t and this is your ut. Okay, ut. Suppose we have this wave shape. Suppose this unit step is starting at t is equal to a. So this step is starting at t is equal to 0, and this unit step is starting at t is equal to a. Okay. So we can have another. Suppose this wave shape. Suppose wave shape we are taking this ut minus b. Okay. So one unit step which is starting at t is equal to 0. There is another unit step which is starting at t is equal to a. So this is called shifted unit step. Okay. This value is, suppose this is 1, this is 1, and this is also 1. So this wave shape is starting at t is equal to a, and this wave shape is starting at t is equal to b. Suppose we subtract this wave shape from this, we get this. Try to understand how we'll get this square pulse. So basically it is a combination of two shifted unit step. One unit step is starting at t is equal to a, and another one is starting at t is equal to b. So if we subtract this portion ut minus b from ut minus a, we get this unit step. So basically ft is nothing but it is combination of two unit step, ut minus a and ut minus b. So this square pulse we can get by synthesizing two shifted unit step. So look at here, this is unit step. Take the unit step, shift this unit step by t minus a. Take another shifted unit step which is starting at t is equal to b. So this is basically ut minus b. This is basically t minus b. So if we suppose deduct this portion from this one, we get this square pulse. Suppose this portion we deduct from here, so we get this. So basically this is u. Okay. So where a square pulse can be synthesized or can be constructed using the two shifted unit step. So this is the very simple waveform synthesis. We can take the Laplace transform of this. So ut minus a is Laplace transform of ut is 1 by s. If it shifted, so it will be minus a by s b, and this is the Laplace transform of this wave. Suppose synthesize sawtooth and find Laplace transform. So suppose this wave shape is given. This wave shape is given. This is your, say this is your F1t. Okay, this. So this is basically, this is RT. Okay, so this F1t is equal to RT, which is nothing but T, linearly increases with time. So this line has one slope 1, okay, and it is increases with time t. But look at here, we can see that this wave form is starting at t is equal to 0 and it terminates at t is equal to capital T. So suppose you take another wave shape. Suppose try to understand this one. What is the equation of this line? Suppose this line is going this one. So what is difference between this and this? Because here it has constant slope of 1, where we can see that after some time, suppose after some time t, the slope becomes 0. So the F1t is increases linearly with time, whereas we can see that at t is equal to capital T, the slope of F1t becomes 0, and then it increases with time t. So suppose if we deduct the slope at t is equal to here, suppose at t is equal to here, we add a negative ramp. This is your positive ramp. This is your positive ramp. At t is equal to a, or t is equal to, say, so we can see that this is at time t. So this is r t minus t. So this line has positive slope. Suppose we have this line. So this r t minus t. So it is negative slope. So if we add negative slope at t is equal to t, this line will become horizontal, or the slope will be 0. So we can write the mathematical expression for this F2t is RT, okay, minus R t minus t. So this is the equation of this line. What we have done, we have just added a negative slope here. So instead of increasing linearly with time, it becomes constant. Okay. Now look at here. Suppose if we deduct this portion, from this wave shape, suppose we just add, suppose take we another, suppose at t is equal to t, we take this step we take, say this is F3t and this is u t minus t. Okay, take another shifted unit step. This is one for t greater than t. This is 1, and this portion is 0. So if we deduct these portions, what we have to do? We have to subtract this portion of the wave shape. So finally we can see that. So it is basically combination of, we can write here ft, we can write here the ramp. This RT is increasing from 0 to t. It increases linearly with time, but if we deduct of same slope is here, slope is 1, or we can say that the slope is e by t. So this is r t minus t minus u t minus t. Okay, But here we can see that the slope is e by t, so we can multiply e by t here, okay, then e by t here, and then the height of this shifted unit step is, in place of 1, it is e. So in place of 1 we write e. So finally the waveform synthesis of this waveform is e by t. E by t is nothing but slope of this line. This is your theta, so tan theta is equal to e by t, which is the slope of the line, and we deduct the same slope at t is equal to capital T. So same slope e by t we are deducting where at t is equal to capital T. So we just what we are going to do here, we adding a shifted ramp with negative slope, and then this line becomes horizontal to the time axis, or it is parallel to the time axis. So we just deduct this portion, so we get this. So finally this is t, then e by t, this is rt minus t, minus e u t minus t. If we take the Laplace transform of this function, so it is coming e by t, and the of the ramp, we know that it is s square, so e by t s square, here e by t s square, so it is a shifted ramp, and we just multiplied a delayed function ts, then we e by s e to the minus ts. So this is the time shifting property. What we have done here, I have used the time shifting property of Laplace transform. So the Laplace transform of ramp is 1 by s square, and this is the slope. Laplace transform of a shifted ramp is, we multiplied e to the minus ts. So 1 by s square into ts, and slope is e by t. Similarly here, shifted unit step, so it is for the unit step the Laplace transform is 1 by s, and for the shifted unit step we multiplied with this function e to the minus ts. So time shift, we have used the time shifting property of Laplace transform. So just here I have explained. So take the, we know that the what is the equation of this line, EUT. What is the equation of this line? It is EU t minus t. So it is a unit step, shifted unit step. Then take the, what is this? This is a ramp with slope e by t into t. So f3t is e by t rt. So this is the equation of this line. This is the equation of this line. This is the equation of this line. Okay. What is the equation of this line? Equation of this line is e by t r t minus t. And what is the equation of this line? E by t minus e by t r t minus t. So basically it is f5t is minus e by t r t minus t. So basic difference between this f4t and f5t, it is with positive slope, it is with negative slope, and both are shifted ramp. So using this wave shapes, we can construct this waveforms. So what you have to do, we have to take this one ramp, this one, okay, this ramp, and then this. So what we have to do, we have to take this one, okay, then this one, so slope becomes horizontal, and then this one. So using these three, this is 1, this is your 2, and this is your 3. So only 3 waveforms we can construct this sawtooth waveform. So this is the final. This is the final equation of your sawtooth of one cycle. So this way we construct. What we have used? We have used one shifted ramp ramp and shifted unit step. Using these three functions, we can construct a sawtooth. So this way we can see the another example of, and this is the Laplace transform. Suppose this wave shape, we have to synthesize this waveform. So what we can see here, this is a ramp starting at t is equal to 0. Okay, at t is equal to t0, its slope becomes 0. So what you have to do, you have to add negative ramp at t is equal to t0. Okay, we get this. Now look at here, at t is equal to t minus t0, the slope becomes negative. What is the slope of this line? This line is, this is E or this is T. So again it is t0, t minus t0. So it is t0. So it is t0. So it is, the slope is E by t0. Okay. So what you, then this line is along the time axis. So what we have to do, we have to add a positive ramp here, because this line is going with negative slope with increasing time. So when we add, this line is like this. Okay, if we add this ramp with positive slope here, line will become horizontal, or the slope becomes 0. So this way, so this is xt is equal to E by t0 RT. So this of this line, so this is the equation of this line. Then here we have added this this slope with negative E by t0, here positive slope. This is the positive slope. Here negative slope. So the line becomes horizontal, or slope becomes 0. Look at here, at t is equal to t minus t0, the slope becomes negative. So what you have to do, we have to add a negative slope at t is equal to, so we can here, I am writing here, later we can check. So E by t0 RT of this line from 0 to t0. If we add a negative slope, E by t0, where at t is equal to t0. So basically we have a added a shifted ramp with negative slope at t is equal to t0. The line becomes horizontal. Again we can see that at t is equal to t minus t0, the slope is negative. So we add negative slope. Slope is E by t0. So this is E, or this is your t0. This length is t0. This is t0. So E by t0, and where we are adding, where t minus t0. Again a negative slope at t is equal to t minus t0. So it is increasing. Okay. Now we can see at t is equal to t, capital T, the line becomes horizontal, or slope becomes 0. So what we have to do, we have to add a positive slope. How much? Of E by t0. This is the negative slope, and this is the positive slope. If we add this slope, the slope becomes 0, where at r is equal to t, so t minus t. What we are going to do here, at t is equal to capital T, we are adding a shifted ramp with positive slope, so line becomes 0, and this is going. So this is the final equation of this wave shape, which is combination of ramp, shifted ramp, shifted ramp, shifted ramp. So these equations, this wave shape can be written in terms of shifted ramp. So this is the equation. This is the final equation. So this is the equation, and then we can take the Laplace transform. So this is the ramp. So we can write here E by t0, and RT is 1 by s square. Okay, minus E by t0, 1 by s square. We know the Laplace transform of ramp, and it is shifted. So it's t0 into s here, minus E by t0, ramp again 1 by s square, and shifted by minus t minus t0 into s. Okay, plus it is also ramp, so E by t0 s square e to the power minus ts. So this is the Laplace transform of this. So finally we can get. So any complex wave shape form can be synthesized in terms of either unit step or ramp. Look at this. So basically we can see that this signal is starting at t is equal to minus t. So suppose a line is like this. Line is like this. Suppose it is minus 2. Okay. Or suppose this is your, say this is f1t. Try to understand. And suppose this is 2. This is your 2. So 2. So if you are required to write the equation of this f1t, how will you write? This is f1t equal to, so it is a advanced unit step. So 2ut plus 2. 2ut plus 2. Okay. So this is the equation of this line. But we can see that at t is equal to minus 2, the line is decreasing. There is a slope. There is a negative slope at t is equal to minus 2. And what is the equation of this line? This is the, so at t is equal to minus 2, 0, height is 2. So basically what is the slope of this line? The slope of this line is 2 by 2, 1. So basically it is a ramp with negative slope. So we can, xt is equal to, we can write here, xt is equal to 2ut plus 2, okay, of this function. And at the same time there is a ramp with negative slope. So it is minus r t plus 2. Okay, it is an advanced ramp. Okay, here with negative slope, and it is going. This line is going because slope of this line is same. So same slope. At here, if we add a positive ramp here at t is equal to 2, the line will become horizontal or slope will become 0. So here we add same slope is 1, so it is 1, and the ramp is t minus 2. So this line will, if we add this function, this line will go like this. And if we subtract this portion, we get this. So then minus and minus 2ut minus 2. So this is the equation of this line. This our wave shape. This is the equations. Look at here. 1, advanced unit step at t is equal to minus 2. So this, and at the same time there is a ramp with negative slope. So this, and this is also a advanced ramp, and we have added a positive slope here. So positive slope, this is a minus 1, so it is plus 1, t minus 2. So line becomes horizontal, slope becomes 0. So add this portion. So minus this and this, we can see that there the magnitude is -2, where -2. So finally we can write this one. So this way we can write the equations of this wave shape in terms of advanced unit step, advanced ramp, unit step. And then we can take the Laplace transform. Okay. So this equation is in terms of unit step and ramp, whereas the lower one, this one is in terms of unit step. Okay. So this we can use the relationship between the ramp and unit step. We can get these equations. Okay. Now this type of wave shape. So look at here. Try to understand. This is ramp. This is ramp. This is also a ramp. This is also a ramp. And then the at t equal to 40, the line becomes horizontal. So what we do, if you start writing, so it is xt. Xt is equal to, what is the slope of this line? A by t rt. Okay. Now at t is equal to capital T, the slope is negative. The first slope is positive, then slope negative. The first slope will become 0, then negative. So what we will do, just we add 2a by t at r t minus t. One slope is a by t. If we add minus a by t, so it will be, slope will be 0. And again we deduct another a by t, so it will be going. And where at t is equal to t. And this line is, the slope of this line and this line is same. Look at here. Okay, 2a by t. Now at t is equal to, this line is going like this. But if we deduct or we add positive slope here at t is equal to 3t, the line will become parallel to the time axis, means slope is 0. So this we have added, this slope, this much we have added here. So line is going this. Again then negative slope a by t rt minus 40. So this line is going like this, and then rt minus 40. So this line so there is some confused mistakes here. Xt is equal to a by t rt minus 2a by t rt minus t. Okay, at t is equal to t3, so we are adding a positive slope. This slope we can add, the slope of this line is, this is your a and this is t, so a by t. So if we add, we can write A by t in place of suppose, so one take A by t rt minus 3t. Okay, so this line becomes this way. If we are adding this, if we add another slope A by t rt minus 3t, so this line will just increase with time, and it is increasing. So here what we have to do, we have to, at t is equal to 4, we have to add a negative slope. So minus A by t r t minus 4t. So for this we get this one and we get this one. Okay, so this two has been combined here, so basically same. So this way we can construct, and now we can take the Laplace transform. The Laplace transform of this is, so this is axis, so this is axis is A by t 1 by s square of this minus 2a upon t s square e minus ts, this shifted. Okay, then come to the third one, plus A by t s square into e minus 3ts plus A by t s square e minus 3ts minus A by t s square e minus 4ts. So this is the Laplace transform of this function. So what you have to do, if the function is given, try to write in forms of unit step and ramp function, and then take the Laplace transform. Now come to the final one here. So this is the ramp. Okay, from 0 to t, positive slope is A by t, deduct the slope here, minus A by t here, we get this wave, then again deduct, because slope is same, slope of this line and slope of this line is same, because it is height is e and duration t, so E by t, same slope. So add a negative here, then add positive here, again positive here, and again here at t is equal to a t, we deduct a ramp. So we can write, so this is A by t rt minus A by t rt minus t. So basically this is the equation of this line, this is okay. Now come to here, at t is equal to 3t, we add a negative slope, so A by t rt minus t. So this is the equation of this line, this one. Okay, now we can say, we can see here the slope becomes 0 at t is equal to 5t. So what we have to do, we have to add a ramp with positive slope, where at t is equal to 5t. So a by t r t minus 5t. So this is the positive slope, this is the negative slope. So line becomes horizontal till 7t. So at t is equal to 7t, what you have to do, we have to give the positive slope. So from 0 to it will increase rt minus 70, this one. So here we have positive slope, and this line is increasing. So just we have to deduct this portion. So for deducting this, we write this one. So finally we can get the equations of this complex waveform. So finally this is in terms of unit step, this is in terms of ramp function. And this equation is in terms of unit step function. What we have done, we have used this RT is equal to TUT for ramp and unit step. Suppose there is a shifted ramp, so it can be written as T minus T Q T minus T. So these two equations we have used to get the ramp into unit step. So either in the examination the question may be synthesize the given waveform in terms of ramp, or synthesize the given waveform in terms of unit step. So write the equations and then use the relationship between the unit step and ramp. So this is about the waveform synthesis. In the next video lecture we will discuss some other topic. Till then, goodbye. Thank you. Jai Hind.